Let's now discuss conditional statements. The conditional statement of P and Q, denoted P arrow Q, is the proposition if P, then Q. We call P the hypothesis, or antecedent, or premise. I often call it the premise. Q is then the conclusion or the consequence. We often say aloud, P implies Q. I maybe have even defaulted to saying it just a second ago. Let P stand for you pay for my ticket, and W stand for I will watch the movie with you. Express P implies W in words. If you pay for my ticket, then I will watch the movie with you. Now it's important that, again, we're not trying to determine if this is true or false. We're trying to determine if, in particular, that implication is true or false. Is it the case that if I bought your ticket, you would go to the movies with me? So consider two friends. One really wants to see the movie. The other has heard the movie is not very good and is not interested. So he doesn't want to waste his money on a bad movie. When would this statement be true? So the friend who wants to see it walks up to the friend who does not and says, hey, if I buy the ticket, will you go with me? So let's go through the different scenarios here. The first scenario on our truth table there is where you paid for my ticket and I did in fact go watch the movie with you. Was the implication true? Absolutely. I held to my word. The if then was true. You bought the ticket, I did go to the movies. Let's look at the next situation. You paid for my ticket, but I did not go to the movies with you. Well, in that case, the if then clause was not true. The implication was false. The next two are trickier. Let's say that the friend said, if you pay for my ticket, then I will watch it with you. But you did not pay for the ticket. Well, that doesn't mean that if you had purchased it, that I wouldn't have gone. You didn't meet the if. So we have no idea if the implied conclusion, the then, would hold up or not. So this is true, right? It was true. If you happened to pay for it, I would have, gone with you, but you didn't, and I still went anyways. And finally, it's also the case that if you don't pay for it and I don't go, well, the implication still holds true. You'll notice that there's this awkward thing that happens where if P is false, the implication holds true. This will cause us some issues down the line. Try another scenario here. Let G be the Rams win all their games, and D be the idea that they will win their division. The important thing to note here is that the implication is making a statement about what will happen. What will happen if the Rams do in fact win all of their games. It doesn't guarantee anything about what will happen if they don't win all their games. So if they win all their games and they win their division, then the implication held true. If they win all their games but they don't win the division, well, then the implication was clearly false. However, if they don't win all their games, then the implication here is making no statement about what happens then. Kind of like no promises, right? You win your games, all of your games, you're definitely going to win the division. If you don't win all of your games, I'm not making any promises about what's going to happen. Considering one more scenario here, I'm going to kind of change this up so we can read it better. Note I'm breaking the rules here. I'm not using lowercase letters. This is just for this one example to help really illustrate what's happening here. I come to class, right? It's our first day of class, and I say, if you get a 90% on all the exams, you will earn an A. An if-then statement. If you go on to get the 90% on all the exams, and I give you the A at the end of the course, right? You're celebrating. I held up my if-then statement that I told you at the beginning of class. However, if you get your 90 on all your exams and I don't give you an A in the course, you'd be pretty angry about that, and rightfully so, right? I told you if you did this, then I would give you the A. These last two really help to show the caveat here. Say you don't get a 90% on the exams, but I still give you an A in the course. You're happy about that, and I didn't break my promise. My promise was if you got a 90% of the exams, then I would give you an A. Not the reverse. I didn't say anything about that. We'll get to that in a second. There are other ways to get A's in a course, maybe. If you fail to get a 90% on all the exams, so that doesn't happen, and I don't give you an A in the course, well, the if-then was not violated either because you didn't hit the premise. This is not the way people think implications work in everyday conversation. The first thing we have to worry about is what's called a vacuous premise. That is, here's a good example of that. If the moon is made of cream cheese, then I am Superman. Well, if you think about it for a second, that first part there, is the moon made of green cheese? Well, that's false. So we're in the situation, the bottom two rows of my truth table there. Right? Either the moon is made of green cheese and I am Superman, or the moon is made of green cheese and I am not Superman. But the fact of the matter is, you'll never really know, right? If there was some parallel universe where the moon was made of green cheese, maybe I would be Superman there. But it means that I can follow up that if the moon is made of green cheese with anything I want, and the implication will hold true. Because the premise, the moon is made of green cheese, is false. A foregone conclusion. If all polygons are rectangles, then all squares are rectangles. This is kind of the opposite coin of the vacuous premise. The conclusion is true, so the statement is true. Again, looking here at what happens when the conclusion is true, we see that the implication is always true. So it doesn't really matter what the premise is. In other words, you're not getting any additional information. I say some stuff that may or may not be true, and then I give you a conclusion that doesn't actually matter. It's a foregone conclusion. So let's look at some things people try to do with implications not true versus the converse. The converse of P implies Q is Q implies P. Here's an example where the conditional is true, but the converse is false. If a polygon is a square, then it is a rectangle. We know that squares are a subcategory of rectangles, so this is true. If you reverse the if-then, you get something that's not true. If a polygon is a rectangle, then it is a square. So an implication does not go both ways if it's just a regular old condition. Here's another example. Only this time, it's going to work out for us just fine. If x is equal to 2, then x minus 2 is equal to 0. Awesome. The converse, if x minus 2 is equal to 0, then x is 0. Typo there. Then x is equal to 2. Sorry about that. So we can see here that even though I've reversed the if-then statement, I still get something that's true. So the important thing is that when you see a converse, you should get like these warning bells going off. It could be true, or it could not be true. So you want to be really careful with converses. The contrapositive, if the controverse is positive, if P implies Q, is not Q implies not P. Let's take a look at some examples. If a polygon is a square, then it is a rectangle. Contrapositive of that, if a polygon is not a rectangle, then it is not a square. Yep, that holds up. If you live in Illinois, then you live in the US. Again, holds up. If you don't live in the US, then you don't live in Illinois. Contrapositive has the same truth value assignment as the conditional again. Lottery ad, you can't win if you don't play. Contrapositive, if you play, then you can win, also holds up. So the contrapositive has the same truth assignment as P implies Q. And finally, the inverse. The inverse of P implies Q is not P implies not Q. Examples of inverses: if a polygon is a square, then it is a rectangle. The inverse is then, if a polygon is not a square, then it is not a rectangle. But that's not true. If you live in Illinois, then you live in the US. The inverse, if you don't live in Illinois, then you don't live in the US. Again, not true. There are other places to live in the US that are not Illinois. So leads us to biconditionals. The biconditional of P and Q, denoted P with the arrows going both ways, is the proposition P if and only if Q. And you've probably heard that phrase before in some of your other math classes. So we can see here that the truth table assignment is if P and Q have the same truth value, the biconditional holds true. Let P be the concept you pay for my ticket, and W be the concept I will watch the movie with you. Express W biconditional P in words. I will watch the movie with you if and only if you pay for my ticket. So we're back in that scenario with the two friends. And here the friend isn't saying, if you pay my ticket, I will go. Not making that promise. It's a stronger promise. Not only will I go if you buy my ticket, that's the only way I'm going to go. So if you watch the movie, if and only if P, so if they're both true, the friend watched the movie and the ticket was purchased, the biconditional will hold true. They watched the movie, but you didn't pay for their ticket, well, then the biconditional was false. So they said the only way they would watch it is if you paid. They weren't telling the truth. Finally, you paid for their ticket, but they didn't watch it with you. Well, then they weren't telling the truth again. And finally, you didn't buy the ticket. They didn't watch it with you. Well, they went through with kind of their ultimatum, right? Hey, the only way I'll watch it is if you buy the ticket. If you didn't buy the ticket, they didn't watch the movie with you. Also true. Let's take a look at one more example here. You will pass this exam is P. You study hard is S. P biconditional S then stands for the idea you will pass this exam if and only if you study hard. In the first case there, you pass the exam and you studied hard. Both of those are true statements. So the biconditional was true. The second scenario there, you passed the exam, but you didn't study hard. Well, then that wasn't the only way to pass. You didn't pass the exam, but you studied hard. Well, that means the if didn't hold up there. And finally, you didn't study hard, you didn't pass. Well, I guess that statement that the only way to pass was to study hard was true.